The RTAL plant at Tilbury is split into two sections, the dry side where the aggregate is fired and the wet side for the dewatering of sludges. The process starts with ash from the coal-fired power station adjacent to the site in one silo and clay in the other. These two materials are mixed together and then sludge is added before being fed into a rotary pan pelletizer. The total mix at this point contains some 20% moisture. The pellet size is governed by the duration in the pelletizer. These pellets are then fed through a polishing drum which puts a skin on the pellets before being fed to a fluidized bed dryer. The pellets are then fed into a rotary kiln. The internals of which still maintain the essential trefoil profile. The pellets are fired at a temperature of close to 1200 degrees C before exiting via combustion air preheater and then a fluid bed cooler before the material is taken to stockpile.
This model is used to illustrate the benefits of the trefoil kiln. A conventional rotary kiln has a rotating bed at the bottom of the kiln here. That bed is heated by two main sources. One is contact with the outside surface area of the kiln, and the second is the direct heat from the centre of the kiln. But there is a section of material that remains in the centre of that rotating mass which is never exposed to either of those two heat sources, and consequently the quality of material that comes out varies to some extent because of different exposure to temperature. In the trefoil kiln that is a very different process. As can be seen here, all of the material on each rotation tumbles from one part of the trefoil into another, getting complete exposure to the temperature. All parts of the material have been equally fired. Another major source of heat on any rotary kiln as well is the reflected heat that comes across. On a rotary kiln, the heat from here will be reflected across to that side, but if there is no bed there, then that temperature is effectively not utilised. Because of the trefoil kiln, every trefoil is reflecting its heat across to the other kiln, to the other section of the kiln, and therefore the concentration of heat to the part of the material that's actually being heated is so much more efficient.
Lightweight aggregate can be made in many forms and has many uses. From the manufacture of lightweight blocks, usually used for their thermal qualities, to precast concrete sections for prefabricated structures, from simple panels to major bridge sections. Lightweight aggregate is also widely used for in situ concrete construction, where weight is an important factor for both foundation loading and increasing concrete structural spans. We have come a long way since Roman times, but in terms of lightweight aggregate production and utilisation, we have only just begun.
The original pilot plant comprised of a high temperature trefoil kiln, an intermediate burnout kiln and a static pellet dryer. This plant was located in Kent. Following discussions with Anglian Water, the pilot plant was relocated to the site at Tilbury and was re-engineered to take specifically the materials available at the Tilbury plant, including the Anglian Water sludge and the ash from the adjacent power station. This plant operated for 18 months.